Now that we've learned that strings behave a lot like lists, it may not surprise you that strings also have built-in methods. Here's a table showing just some of the string methods that are available in Python for transforming the string, searching the string, evaluating the string, and more. I encourage you to take a look at the Python documentation to see the full list of all possible methods built into strings in Python. Now with all the string methods, as with all the list methods, in order to access them we have SumString, here I call it S, dot, and then the name of the method. Now you're not required to memorize all of these methods, but you should become familiar with the most common ones. We'll do some practice in just a moment, but I want to remind everyone that because strings are immutable, there's a small difference between how these methods operate and how the list methods operated. With the list methods, like append and pop, we saw they mutate the list itself, so they change the values within the list, but the list itself stays effectively the same entity in memory. But recall that strings are immutable, so we can't mutate strings. We have to make a new string. So these string methods, even though they're operating on some string, they don't change the string itself. They'll always return some new string when necessary. So let's move on now to do some practice with these. Returning to VS Code, I've pre-written this function called string methods, which just takes in a string and applies a number of the built-in string methods to it. So we can see the effect that those methods would have on our input string. And then down at the bottom we call that function with the string 11 benevolent elephants. So let's see what happens when we run this. We'll say python stringmethods.py. We run our code and we get a bunch of output. So our input string was 11 benevolent elephants with a bunch of spaces at the beginning and a tab at the end. The very first thing that happens is we print out the input string. So we get that exact input string. Notice we still have our spaces at the beginning. There might be a tab at the end, it's hard to tell. The next thing it does is prints out the length of that string, so there's 34 characters in that string. And then we say s.upper. So printing out s.upper, we get the same string that we put in, but all uppercase. But notice, the very next line we say print the string itself, and it is unmodified. Which is to say the thing that s.upper returns is a new string that has all the same characters, but uppercased. The original string does not get modified. So the next line says s.lower, and we can see the same sort of thing. It's the input string, but with all the uppercase, the one uppercase letter moved into a lowercase letter. There's also something called title case, which just uppercases the first word of every letter. The strip function tends to be quite useful, so if you have some data that you're taking from some messy place, like you're parsing through some file and you're pulling chunks of that file out, and you want to have individual words, or let's say you're getting some user input and there might be some empty spaces around that user input, strip takes any of the remaining white space at the beginning or end of your string. So it strips away the outside white space, and that leaves just the core character strings in the middle. So if we had our input string with spaces at the beginning and tabs at the end, when we say s.strip, we get just the string. Notice all the spaces at the beginning are gone. I can tell you the tabs at the end are gone as well, although you can't really tell. The next line says s.count and passes in the value e. So count lets us count the number of occurrences of a given token. So we have a single character here, but they could be whole words. And what this function does is it counts the number of times that token shows up in our input string. So in this case, we got 7 because there are 7 e's. So if I look, we got 1, 2, 3, 4, 5, 6, and 7. Notice it did not count the uppercase e at the beginning because that's a different looking character. If we wanted to count both, one thing we could do, take this whole line here, number of e's or e's. If we wanted to count both the lowercase and uppercase e's, well, we could count both and add them together, or we could say s.lower.count e. So we can chain these operations together. So this is our input string. We say s.lower. So notice our uppercase e is now our lowercase e. So if we apply count to that value, so not to s, but to s.lower, then we're counting the lowercase e at the beginning of the string as well. So if we save and run this, we have 7 e's that are lowercase, but if we're counting both upper and lowercase, then we have 8. The next method is s.replace, and as you might expect, this replaces one value with another. So given some input string, we'll call that s here, we'll say dot replace, and then we give it 2 other strings. The first one is the string to look for, or the token to look for in our input string, and the second argument is the token to replace that with anytime we find it. So in this case, replacing e's with o's, our original string, 11 benevolent elephants, becomes elovon bonovolont oliphants. But after we print s again, notice the original string is still unmodified. So in all the cases, anytime we get a different string as a result from one of these methods, it's a brand new string. The original string is unmodified because, again, strings are immutable. Now there are many more methods available, and I strongly recommend you take a look at the Python documentation to see if there is a method that exists that will help you solve your problem before you start creating some new function that will take in a string and process it. There's a very good chance that some of the basic operations, at least, are already pre-built into Python. There's a couple other functions from the table that are very important that I haven't shown in this string methods demo, so let's make a new function here. Call this one def square a number. And what this is going to do is going to take in some user input, and it's going to square that user input. But we're going to do so in such a way that we don't have to assume anything of the user. If the user doesn't play nicely and enter a number, then we'll handle that gracefully. So let's put a function comment here. We'll say gets a user number and squares it. We already know how to get input from the user, so I'll say some variable num equals input, and then I'll ask the user, please enter a number. Any number will do. Traditionally through this course, the next step has been, if we have a number from the user, is to say num equals int num. That is to say to take the string the user has given us and convert it into an integer, assuming the thing they've typed was an integer. But now we want to avoid making that assumption. So instead of immediately assuming we can do that, we're going to put some sort of check here, some sort of condition to say if this is a number, then we'll make sure we can use it. If it's not, then we won't. Turns out there's a built-in string method for determining if the string itself contains a whole digit. Let's come down to the interactions area here. If I say Python, if I have some string that has some number in it, I can say .isDigit, the built-in method, and that returns true or false if the thing inside that string contains only numerical digits. That is to say, if it could be converted into an integer. Notice if I say the word 3.isDigit, I get false. If I say 3x.isDigit, that's also false. The entire string itself needs to be convertible into an integer, then this will return true, otherwise it returns false. Notice this is only for integers. If I say 3.14.isDigit, then that's false as well. Let's clear this up and back to our code. So we've gotten some input from the user. We've got this string that they've given us that should be a number but might not be. So let's check if it is a number. We'll say if num.isDigit. If this is true, then the thing they've typed can be converted into an integer. So let's convert that into an integer. And then the task of this function is to square that number. So we'll say print your number squared is, and then I'll just say num squared. Now, if they don't give us a digit, maybe we can give them some sort of warning or loop again and ask, but in this case, I'll just say print, I asked for a number. That way we'll give them some feedback that they didn't enter a number. So let's save this and try it out. I'll say python string methods.py. I want to make sure I run my code. So I'll call square a number. We're given a prompt for a number, so let's just give it a number. There's my number squared. I can believe that that's true. Let's do a number that we know. That seems to work as well. And let's try something else like the word 3. And it says I asked for a number. And it exits gracefully. So notice we don't get a crash now when the user passes in some invalid integer and we try to convert that into an integer anyways. Now, if we wanted to solve this to allow the user to type in floating point numbers, there's no built-in string.isFloat like there is an isDigit function. So in order to solve this, we actually don't have enough tools in our toolkit yet, so we'll have to revisit this problem in the next chapter when we learn about exceptions. All right, that's the isDigit method. The next method I want to show is the split method. Let's do that in our interactions area first here. So if I say Python, take some string like hello world, I can say, let's call this s. Then I can say s.split. It takes the input string and separates it into a list of smaller strings. By default, when we use split without any arguments, it splits based on white space, so any spaces, tabs, or new lines. If instead we change the token, so if I have some string A, B, C, D, E, F, G, for example, and I said dot split on the underscore character. Again, these tokens can be many characters long, but for demonstration, it's easier to see with single characters. It takes our input string and based on the underscore character, splits that input into a list of substrings. So I'll just put this back into our string methods demo here. So I could say print split by spaces. If we want to split by white space, we can just use the default argument. If we want to split by any other value, we can include that as the argument. So let's save and try this out. Python string methods. Let's make sure we're actually calling our function. And we can see our split. The first one by spaces, which just gives us separate words, and the next one by e's, which gives us some interesting garbage because there's a lot of e's in there, so we just get a bunch of smaller strings. But notice if you put an e in between all of those, you get back to your original string. In fact, to demonstrate that, let's look at one more string method. This method is called join, and it effectively does the reverse of the split method. So where split takes in some token and splits our input based on that token, join takes in some list and merges it together based on some token. Now the syntax here is a little bit strange, so let me just type it out and then I'll walk you through how it works. So I could say and as my string dot join, and then we'll use the list 1, 2, 3, 4. So notice this is still a string method, so we still say SomeString.join, and then as the argument to that, the list that we're trying to join. This might seem a little bit backwards because we're using the token as the string that we're getting the method out of, and we're passing in this list. But the way to remember this is that it is a string method, so the string has to be in front of the dot in order to get that method. If the list were in front of the dot, then we'd be using a list method. So what this does is it takes an input list filled with strings, and it joins it into one big string by inserting the value before the dot between each item in that list. So it says 1, and then it takes a token, then 2, takes a token, 3, then token, 4. So 1 and 2 and 3 and 4. So similarly, if we had our output from before, so this list here, we can paste this into our command and say in front of that the letter E dot join, and then this whole list, and we should get our original string back, 11 benevolent elephants. And the last string method I'd like to show you is the find method. So find takes some string dot find, and then you pass in a token that you would like to find in that string. And what it will return is the index of the first character in that token if it's in your string. If it's not in your string, it will return -1 because -1 is an index that's not in your list. So for example, if I have a string hi equals hello world, I can say hi.find, and then pass in some token that I'd like to find. So let's say, where is the LLO in hello world? And that returns index 2. So notice we have 0, 1, 2. So it gives us the index of the start of that token in our string, assuming it's there. If I were to ask for something else like hi.find QXV, that's not in hello world, so we get -1. So it's a signal that the search didn't work. Notice if we have multiples, so if I say hi.find the letter O, for example, because we have 2 O's in our input string, it will tell me the first one. So it'll tell me the index of this first O and not the second O. If we'd like to find the index of any remaining value, so if we have duplicates and we want to check is there more, we can use a second argument in the find method. So I can say hi.find, looking for the letter O again. But now instead of looking from the beginning, I can pass in an index to say start searching from this index. So if I know my last O is at 4, I can say start searching from index 5. And it says the next O is at index 7. So in our string methods, for example, we could say something like index of the first V character is s.find V. Save and run our code, and it says the first V is at 8. So you can count that, but it's counting all the spaces and then to there. Now with this information, let's do a quick little impromptu challenge. Let's write a function called findAll, which, given some string and some search token, we can return a list of all of the indices where we found that value. So let's bring our code up here, comment this out, and we'll make a new function down here, def findAll. So this takes in 2 values. We'll say s and a token. where S is the input string and token is the thing we're trying to find in that input string. And to describe this function, this takes in an input string and a token and returns a list of all of the indices of that token in the list. Now, I encourage you to pause the video and see if you can solve this on your own using what we've covered here, but now let's walk through it together. So we have this input string. We want to find that token in the input string, and we just saw there's a built-in method that lets us do that. So we're going to apply the find function. But now if we want to find the first instance, and then the second instance, and the third instance, and possibly the 100th instance if we have some large string, we need to be doing this in a loop. We don't want to manually walk through that every time. And at the end of all this, if we want to return a list of all of the values that we found, of all the indices that we found this token at, then we're going to need some sort of list that we're building up as we go through that. So we've seen a similar solution like this. We're just going to traverse through our string. But now instead of traversing one step at a time, we're going to be using the find function to help us jump through that string. That way we don't have to traverse every single character and say, is this the token, is this the token? The find function can do that part for us, and we just need to repeatedly use the find function to step or jump through this string. So let's start by initializing our output. So we'll say result equals the empty list. Bring this up here. And the first step in this process is to find the first instance of our token. So we'll say index equals s.find, and then just the name of our token. In this case, since we're starting at the beginning of our string, we don't have some previous instance of this token already found. We don't have a second argument. We're just saying s.find the token for the first time. Now there's two possible outcomes of this. Either we find the token or we don't. In the case where we find the token, we want to then add that value, the index that it returns, to our result, and then repeatedly find the next token in the next one. In the case where it doesn't find the token, that means it's not there anywhere, because this was our first attempt and it didn't find any, then we can just return this empty list that we've already got. All of which is to say, we need a conditional here and some repetition. So I'm going to combine these into a while loop. I'll say while index. And now the condition that we want to continue searching is so long as we keep finding instances of this token. And the condition where we want to stop is where the index is -1 because we didn't find the token. So we can say, so long as the index does not equal -1, let's keep searching. Until we find that it's not there, let's keep checking if there's more. Now, if that's true, that index does not equal -1, that means the find that we already did has a value. So the first step is we should save that value to our result. So we'll say results.append index. So we have an empty list. We found the token once. Let's store that. And then let's see if we can search for it some more. So the next search would be s.find token. We still want to find the token. But now instead of starting at the beginning of our string again, we want to start from the place where the last search ended. So we'd say comma index, but now we don't want to find the same thing because we know token is at index. So if we search from index, that's just going to find the same one again. So we'll say index +1. Go one step past where you found the last one and then keep searching. That's going to return either a -1 if it can't find it or a new index if it does. And in either case, we'll store that back in our index variable. That will go back up to the top of the loop. If it didn't find it, then we'll stop. If it did find it, then we'll append that and search again. Eventually, since find is constantly moving forwards because we have this +1 in here, we're guaranteed to eventually reach the end of the string, at which point this index has to be -1, because if there's no more string, then there's no more token in that string. And at that point, we found all the possible instances of that token in our string, so we can just finish our function, return result. All right, let's save and test this out. Bring it up on screen here, and let's make sure we're calling our function. So I'll say find all. And let's call this with some string like hello world. And we'll look for the list of all the L's in that string. And let's just print it out so the user can see that the code worked. We run our code, we get 2, 3, and 9. So 2, 3 would be 2 and 3, and then 9 way down here. So that looks to be working. And now, in addition to all of the string methods, you also have this handy function, which applies one of those string methods, the find method, to find all instances of a token in a given string. All right, so as I said, there's lots more string methods available. I strongly recommend you take a look at the Python documentation to see which ones are available to you. Chances are, if you're given some task that involves string processing, all or part of that task are probably already built into an existing string method. So you can save yourself some time by doing a little bit of background research, using the existing methods where possible, and then expanding those where necessary.